Hello, hello,
Hey,
hello.
hello. Welcome back to the Routing Loop. Joined to get today once again by my partner in crime, Matt Lewis. Matt, say hi.
Hello, hello.
And
How we
today we're
doing?
going to do an Ask Me Anything. So, Matt, what's been going on in your life lately? What's going on in the wonderful world of networking?
Ask me anything. Well, I guess I don't know if I guess I told folks that I work in EC2, and so I work on less networking things, but I still work on networking. So I guess quick history for folks who might be just tuning in for the first time. And Jamie, maybe you can do a reintroduction on yourself too. I'm Matt Lewis. I used to be a network engineer, and I've worked on AWS for the last almost 13 years now. And I was working in Networking Services, which is an organization that owns Transit Gateway, I guess, what else? CloudWAN. Now that org is responsible for things like network firewall, gateway load balancer, network load balancer, a whole bunch of different networking services, hence the name of the org. In recent times, and I guess it's been about a year now, I've moved into EC2 proper. And so I work on EC2 things, which we can talk about a bunch of stuff around that. Outposts is one of the products that is under EC2, and I actually want to share a customer issue without any details that will obviously obfuscate any details that could be identifiable, but a technical issue that we ran into on the weekend. I spent about 5 hours troubleshooting a very interesting problem, so I'll talk about that today. But also, EC2 owns Nitro and instance networking, and maybe we can talk about contract timeouts. I think we just changed the default on those. I don't think we have a blog about that yet, but there's some things around NLB. And I work on some Bedrock things. And I think Jamie and I have been hacking around with Kiro
Yeah.
CLI a lot lately and going back and forth on a bunch of different cool ideas. So maybe we'll jump into a Kiro CLI terminal and see what kind of networking theme-based things we can get up to as well. But yeah,
Yeah.
that's kind of what I've been up to.
But don't let Matt sell you short either. Like, it's really important to understand like his involvement in the throughputs of the NICs on the EC2 instances and our services and all that. So as much as he's telling you he's not in networking, he's still fully in the networking. So
I like
don't
selling myself short. It's all good.
don't sell yourself
Under
short.
promise, over deliver.
And then for me, for folks who are just tuning in, I've been with AWS now for I think a little over 9.5 years. Matt, you've been longer, right? You've been like 12 years now or
Yeah,
something.
almost 13, but I can't believe you've been around almost 10 years. Wow,
Yeah, almost 10
man.
years. So I'm in, for folks that don't know, I'm a principal solutions architect, and I work with the PMs and the PM team and the folks that are in what we call networking services, who make all of the make, produce, design, and that all of the different networking products and services. Which, of course, this team works very closely with Matt's team because Matt's team consumes a lot of these networking services, or in many ways, again, on the ENIs and all the backplanes and things like that, he may set some of the limits or help his team help set some of the limits of what our products can do. So it's actually a kind of a perfect mix of having both sides of the coin of networking on today. So if you have questions and then we're allowed to answer them, please bring them. All right. Don't be shy. You can go ahead and say, hey, why is X, Y, Z, or this or that is happening. But yeah, absolutely. We've been working, Matt and I have been banging around with this Kiro thing. For those of you who may or may not know, Kiro is like an agent. It's basically an AI agent where you can ask it to do stuff on your behalf. And you can create like different things called MCP servers that will let you get and fetch and do all this crazy cool stuff. And of course, being in networking, we've been using it to do things like bring up networking environments, doing tests, and seeing where it fails and where it's good. So that's part of it today. We might be doing a little bit where Matt was like, "All right, this isn't Ask Me Anything." And if you want to show or you want to talk about it, Matt, about pulling in all the blogs and all that fun stuff.
Yeah, let's do that actually, because I thought that was super cool. Uh, so we'll start there. Share
And Ken,
screen.
awesome. Let us know what we're doing right or wrong.
I'm actually logged out of Twitch, so I had to reset my password, and I'm waiting for a code. So I'll be on Twitch in the chat in a minute. But this isn't Ask Me Anything, so any questions, please post them in. We can see them through StreamYard here anyway. Once I get my Twitch logged in, we'll be able to chat real time.
So
Okay,
how is
so
Kiro going to replace Matt at AWS? Thank you, Dominic, for saying it's replacing Matt and not me. So that's
well, I have some thoughts on this. I don't think I'm going to get replaced, and I'll talk specifically to my situation. I think I'm just able to scale. it's incredible the amount of stuff that I'm able to do now. So basically, I just started. This is a chat Jamie and I started a little bit. Oh, I was asking what was burning my CPU, but where are we? So we did some other stuff, and then I basically somewhere here, this is part of it. I said, go out to the AWS. I might be able to find the actual prompt here, but go out to the AWS Content Delivery and Networking blog and pull in all of the blogs for the last 12 months. You can see there's a bunch of, it's like basically slamming the AWS blog. So it did page 7, 8, 9, 10, 11. And it's just a really simple prompt. If I can find it here.
I think there's a way to recall the prompt. So.
This one. Okay, so this is the prompt that we ran here. So can you have a look at the AWS Content Delivery and Networking blog and ingest the last 12 months of blogs? Wow. Okay. Now, why would we want to do that? The idea is we want to basically, within this context, be able to ask it questions, build different frameworks, tell us different trends on what AWS has been releasing, create a newsletter. Maybe, I don't know, could you do this every single day and then create a newsletter? Maybe like Corey Quinn's last in AWS. Hi, Corey.
Have it Slack you like, hey, here's your morning Slack of, self-generated AI content /slop if we don't curate it well, which we should talk about curation too.
Yeah, the curation is probably key. So here, done. And it didn't work properly. I'll tell you what happened in a second, but I've compiled and ingested 120 blogs from networking content delivery since April 25 to April 26. Index is saved here. Forget that's just my internal directory, but this is the kind of posts that it includes. Now, we were kind of led along a little bit here because then we said, okay, well, there's not a lot of detail here. Does this include the actual blogs or just the headings? Oh, my bad, it's just the headings. So then we had to go back, and I gave it some caps here. I sound like I'm being
got a little mad.
I wasn't being mean. I'm not a mean person, but the capitalization here just helps say this is actually important. I want you to actually go and don't be lazy. Go do this stuff. And so then there's a bunch of context here, but the end result is it spun up a bunch of different agents to go and in parallel try and get the blogs and content, and there's a bunch of stuff here. But then we started getting to the good stuff done. All 120 blogs with full context are now indexed in your knowledge base. Great. Okay, so we started asking, well, tell us what launched in Lattice, the formatting's kind of punk, but we can ask it a whole bunch of, I accidentally pasted something here. I shouldn't, it's just a random copy paste. Let me delete that. So now we can ask it something like, to the question Jamie asked, is Matt being replaced by AI? And I say, no, I'm being augmented by AI. Well, Blade Runner style or something, but yeah. I'm going to say, based on the last, excuse any typos. When people watch me type, I make typos everywhere. But based on the last 12 months of blogs that we now have indexed, create a new framework for the advanced VPC design and new capabilities session for reInvent 2026. Let's see what.
It's the first time he's typing this prompt, just so you know.
I have not. We were talking about, oh, maybe I'll make it build my reInvent session this year as a joke, but let's see what it actually comes up with.
So and also, just to bring up stuff. Can we get a session on EC2 Nitro networking? Absolutely.
Yes, we
just
can.
To let you know, the last reInvent, Matt and I did along with Milind Kulkarni, an excellent PM from Network Load Balancing, we did a session on the evolution of AWS ELB, of Elastic Load Balancing. And Matt did get into some of the evolution and some about the Nitro. So if you haven't checked out that video, please do. He does a really good job in the beginning. If you want to just do only the Nitro thing, I picked up on some of the other stuff, but it's actually pretty cool. Yeah, we could do Cloud WAN too.
I would actually love to dig into, and maybe I have some friends from EC2 that have gone over to Annapurna, and I'd love us to talk about, how do our I say smart NIC because that's kind of the industry term, but our Nitro cards, how do they work? How do they function? How do packets get sequentially passed through different buffers, and why, like, how would quality of service work in AWS, and why that would or wouldn't be a good idea and applicable to how we do Nitro, and how to think about things like GRE packets going through a Nitro card and how we would actually look at different headers of that and do 3-tuple hashing instead of 5-tuple hashing on CPU cores in a Nitro adapter, and how different generations of Nitro cards operate differently and have a higher clock speed. And that's just a preview on what we should talk about with Nitro. I think that'd be a cool session.
And then also don't forget about the practical applications, like some of the things that Nitro drives, like VPC encryption controls, and how do we actually apply Nitro to things like ALB, where it spawns things on the side. Sidecar VPC brings up different nodes and then uses Nitro instances as opposed to standard instances, so that everything that goes back and forth has a layer of hardware encryption within the VPC. So I think we should also talk about the larger ramifications of that too, or you should, if you're going to run the show and leave me behind in the dust with all your new EC2 friends.
No, you can join for sure. Sorry, I'm just logging back into Twitch here. Okay. And let me mute that so I can't hear myself, which is really distracting. All right, let's come back to, so there is apparently a bug where if you're running out of hard disk space, the screen share randomly stops. And sadly, I'm running out of hard disk space. So I won't do that now, but later I'm going to ask QRCLI to find all the big files that I have. Oh, I hope that doesn't keep happening, because that's really annoying. I might have to actually go and delete something now. But let's see what happens here. Okay, so we asked it to create advanced VPC design. Let's see what it came up with. What do we got here? So, oh no, this is really annoying. I wonder if there's any way I can get beyond that.
Yeah, that'd be.
I cleared my recycle bin, but maybe if I kill something else, let me quit a few things that. So with Mac memory management, basically things consume hard disk space, and if I kill a bunch of applications, that should in theory free that virtual RAM. I'm going to try not to kill my let's see what else we got here.
So this is the cost of AI.
Well, I have a pretty powerful laptop. I have it's like an M3 Max or something with a bunch of RAM, and I've been running 100% CPU on this sucker for a couple of weeks now. All right. Oh, that's not going to work for us. Okay, we might have to pivot if I can't get to the answers here, or maybe I can dump them in something else. Let's try one more time real quick, and then while you're talking and telling us about something, Jamie, I'll clear some of my hard disk space. Okay, yeah, let's try one more time.
Go ahead.
Okay, so we've got an opening here. VPCs evolve. We've got module 1. Okay, application networking. I like that. Module 2, cross-region, cross-cloud connectivity, multi-cloud launched. I think it was public now. It's full GA, even though we talked about it at reInvent. Security and governance. There's some good stuff there. This is a full framework for what advanced VPC design will probably be this year, not counting everything we launched from April to the end of this year. Closing. This is incredible. I love this. I don't know what you folks think.
And is it? But the thing is it relevant?
I think so. I mean, based on everything that we've just recently launched, absolutely.
It looks very compelling. And it's all drawn from the knowledge base too. Because one of the things you want to make sure of that we've been finding out as well is, like, to talk about Matt's scale with this tool, or my scale, right, for what I've been doing. One of the things I did to talk to Dominic's point is I've been building up something that will allow people to easily learn more about VPC Lattice. There's a lot of knobs and dials now. We have the API controller. You can connect with ECS. You can connect with the EKS with the controller, as mentioned. It's natural services, service network endpoints. There's like a lot to that ecosystem that kind of blew up really, really fast. And for everyone in the know and that's been using it, it's like, oh yeah, one more feature, one more cool thing, one more feature, one more cool thing. But if you're trying to adopt it from zero, it can be quite compelling. So what I did with this Kiro thing is I said, I want to build a complex environment that has all those attachments, and I want it to build it, this Kiro thing to build it for me, and then learn from its mistakes. And the deal is like, I would have just sent it and said, go ahead, build, do whatever you want to do, and walk away. It built all the VPCs, right? It built those out on the initial design. Service Network 3 VPCs built them just fine. Every VPC had an IGW. Everybody had access to the internet. And my explicit instructions were, I want no IGWs. I want this to be secure. So it comes back almost whining to me, telling me, but I need to have access to be able to pull some of that dummy data that you want. And I'm like, did you forget about VPC endpoints? So then they're like, oh yeah, it's a great idea. So then it goes and redesigns. Now, if I were to ask it to deploy a system from all of the things that it learned, it knows that when I say I want this to be internal only, I don't want to have any IGWs, I want it to be pretty secure, it will go through and build it to that spec. So what does that mean? What that means is if you don't know what you're doing, if you have no clue and you sit down in front of this Kiro thing and say, build me an AWS environment and I want it to host this application and do X, Y, and Z, it will fail miserably because not only will it maybe A, not be able to actually complete, but B, it could be very insecure, right? Or, the security of all the IGWs are open. I had no service policy on my service network when it first built it. So it does need that governance of someone who knows what they're doing to help orchestrate and retrain and relearn. So what you're trading off is, instead of me going to the client or me creating a CFN or me doing all the iterations myself, spending hours and hours and hours doing that, I can do that rapidly with this tool, but this tool still needs my guidance. I guess the analogy I was using when I was trying to explain this to somebody who's non-technical is like, these are like a bunch of idiots with PhDs, right? They have no awareness of what is even moral or right or wrong. They just know what they know. They need a guiding force or guiding governance who also knows that what is possible and what shouldn't be possible to help guide them to do these tasks. And in that way, I've been building out like 3 different environments at once, right? And then doing cross comparisons and all that. This work that I'm doing for a customer would normally take me, my turnaround time is what? 3-4 weeks to do something like that. Hell, just to bring down an EKS cluster takes a half an hour. So
what's an example of like you said, multiple environments at once? What are those multiple environments doing at the same time? Like, why do you need the parallelism versus just a single session?
This comes down to like a Jamie philosophy, right? And the philosophy is this: if I get something to build that I want and I have it laid out, and that's a good point, Victor, by the way, with the cost. If I have it laid out the way that I want and I finally get it to perfect, even though the execution itself wasn't perfect, I need to always remind the tool and myself in many ways what my benchmark is, what I'm working up against. So when I build in the other environments, I'm comparing the two, saying, okay, now that we've got this built, compare it to the other environment. What's different? Do essentially a diff between the two. And sometimes it'll catch, oh yeah, I forgot to add this policy, or I forgot to add this. And we keep adding it into the learning model. So Victor, to answer your question about the big cost, imagine me doing this manually and needing to keep these environments up all the time. When I'm done, I tell the AI agent and the tool, okay, I'm done for the night. My wife is peeling me away from the computer at 9 o'clock at night or whatever it is. I said, I'm done for the night. Shut down the environments, and it shuts them down. So I can save my costs that way, or I can even do a cost estimation, saying, hey, if I were to do it this way, what would the costs be if I were to keep these environments running, for at least a week? Like let me see if I can bring up my Kiro and I can show you exactly what I would do. This, and then see if Matt will actually fix his using.
I think it might be working now. I've found some files to delete. I'm finding I'm using Kiro to find files that I can delete and free up some disk space now. So my screen share will work. Oh, do you want to zoom in a little bit? Maybe just adjust the window size so we can see a little better.
Let me see. Ooh, how's that?
Okay. Yeah, it looks okay to me, but maybe folks in the chat let us know if
yeah, if you can't see. So basically I'm saying, well, let's running. And these are a bunch of things that I've kind of pre-told it how to do for the tool. And I've even built probe tools to actually see what's going on. So I have my full Lattice environment running in 2 regions right now. Right. So now, no, don't tear. This is in the middle of a project. Right, so I wanted to tell what is the cost implications, basically for 1 month. And again, you're going to have to forgive me a little bit on my typing. I'm not as great. So now it's going to go through and it's going to basically tell me. After it's done doing all the comparisons and all of that. So while that's running, Matt, Do you want to try your screen
Well,
again?
Yeah, we can come back to that. I actually like Dominic's comment here. Do you know if anyone internally in AWS is working on Kira Powers or specs for networking stuff? I think there's a couple of folks here and there, but nothing's actually been made official. So I think some of the hacking around that Jamie and I are doing here could potentially turn into Kira Powers, right? I mean, I would love to have for lack of a better term, some kind of super agent that has the right context on networking and looks at the different architectures. And what we were doing with the blog posts ingestion and creating a knowledge base just now, that would be amazing to share with other folks, right? So you don't have to go through, I mean, there's not much pain. We just did it in the last 30 minutes. Anyone can do this, but there's probably other recommendations and well-architected and other things and context we could build into that and create that as some kind of knowledge base or Kira Power to say, hey, you're the AWS cloud networking agent, and you've now got all this context on what the right things to do in AWS are. And so, yes, I think we need to be building stuff like that for sure.
So let's see what this thing has come up with. And by the way, I am working actually on a Kira Power for Lattice. That's what this whole project is for, to help with the knowledge base for folks to get up and ramped and learning. But yeah, here it is. It's basically telling me what my costs are per region. It's telling me what my database, networking, total cost, everything down for both regions. Right now, I'm around $560 a month for my cost, right, for my project. So I can be pretty aware of what's going on and what I'm using just by a couple of inquiries of what I've currently got running. So go ahead, Matt. Let's see if you got.
Yeah, let's. Well, I mean, what I had sharing before is. Let's see if it works now. And I believe it is this one here. Okay. Yes. Okay. So, I mean, basically, we built out the reInvent session that could be presented this year. Are there any other questions that we want to ask this thing that it knows everything as far as what we've launched for the last 12 months? Maybe we can ask it. Oh, there is something that I want to talk about, contract. So tell me about contract timeouts and NLP. I don't know if we've actually talked about that in the blog post. So we did recently change the default timeout for contract on Nitro. And I believe it's about 5 minutes now, whereas it used to be a lot longer. And what that actually does is it preserves memory on the Nitro card. But what we've also found is you can change contract limits on NLB. And so you may set the contract limit on an NLB to be super high intentionally, but then the Nitro default now is much lower at 5 minutes. And so then it's going to take the Nitro timeout because whatever is lowest wins. And so it's something that some folks just weren't aware of. Let's see what we got here. Okay, nothing in the last 12 months. This is a topic covered in the NLB documentation rather than the blog. NLB contract connection. So it's actually gone and it's talking to NLB documentation now. This is pretty good too. So enable TCP, keep alive on client for targets, set this. Okay. TCP idle timeout, 350 seconds fixed. TLS handshake timeout is 15 seconds. I have a blog post which we're writing right now on Nitro contract timeout limits. So watch this space. What else should we ask it, Jamie? Oh, I think my headphones aren't working now. I can't hear you.
No, it's me. It's me. I'm muted.
Oh,
okay. I was going to say we can't ask it any upcoming features or anything new, unfortunately.
I'm afraid to, because it has a bit of context on some stuff I'm working on, and it might just automatically switch to another context window and start talking about some new features we're launching. So I need to be a little careful here.
No, it's true. It's true. So let's see what Dominic's basically saying. Yeah, I've already seen some examples of where it's doing work. So what the question was is, let's ask it about DevOps Agent. Like, how is DevOps Agent able to help? Because I don't know if you saw, but it was recently released in GA.
No, I didn't see that. So what am I asking? How is?
Yeah. So how will DevOps Agent? You can also here, and so this is pretty much the question. I know the answer to this, but let's see what happens.
And my grammar's a little bit off, but I think that's okay, right? You can just say, tell me about DevOps Agent, or DevOps Agent, go. Network troubleshooting, go.
Right. But the short answer is yes. Of course, it can help you. There's a lot of things that it can do, putting probes and stuff out there, looking at your network, and also doing any type of reconciliations with other tools. Like so, making sure that you have enforcement with AWS config for any type of enforcement things. It could also look into again something. I believe it has the ability to look into some cost implications, just like we showed here.
So it's pulling NetworkBlog's network flow monitor, some markdown there, which it doesn't have dates. We don't have detail. This is raw chunks of text here. GenAI building networks. Oh, is probably a good blog post to read. Let's see what it's actually. There are 2 relevant blogs from the last 12 months. Building intelligent network operations agent with Amazon Bedrock Agent Core. Okay. Is that the one that you were referring to, Jamie, or was it a different one?
Yeah, that's the one.
Okay. Building network ops agent using Bedrock, what the agent does. So we're still writing blogs and releasing blogs. There's probably some AI help on the back end. I really, looking at the networking content delivery blog, I don't want to just see AI slop being posted there by AWS solution architects, right? I mean, we're pretty specific around how and what we want to post on that channel. And I think the content will probably get better because someone like me that's not that great at writing blogs can then use this to augment my blog writing capability and come up with some really good ideas that I had and would recently or before this be harder to write. But does that mean you folks, if you build this knowledge base yourself, don't need to read blogs anymore? I don't know. I mean, maybe not. Just give me a summary. Tell me why it's interesting to me.
Yeah, excellent.
Right. Bedrock agent approach lets you build network SRE in a box. Okay, but maybe I've got a problem, right? And maybe I'm interested in something else. I say, okay, but I'm actually interested in, I don't know, NetFlow-like capabilities in Nitro and feeding that to something like, what's the graph data, or what's the visualization tool that everyone uses? Prometheus to Grafana.
Yeah,
My
Grafana.
brain's broken. So we're asking it a fringe topic based, we've got this blog, it knows about this blog, but hey, my problem isn't actually that. It's kind of similar and I need more observability. What else should I be thinking about here? And we'll see what it comes up with. It's going to use that knowledge base and probably look for other things that are similar. But it's found network flow monitor agent, install Nitro TCP structure, round trip latency tree. Okay, well, that sounds interesting. Okay, so we have CloudWatch Network Flow Monitor, launched reInvent 2024, blog from April 3rd, 25. Here's what it does. Okay, so we have a fringe topic. Oh, I think we just lost Jamie. I don't know if he's still here. But so we have a fringe topic now that we think, okay, that's a thread I want to pull on. That's interesting, but it's actually kind of related to something else. So, I mean, super, super interesting stuff. Getting it into Grafana. Okay, CloudWatch Grafana native. Actually, I didn't know there was a native Grafana, and this is AI again, so anything could be AI slop here. We don't know, right? So we want to probably double check everything here. Okay, so we've even got a really cool table. What's missing versus traditional NetFlow IP fix? So round trip latency in network flow monitor has packet loss 5 tuple bytes in, doesn't show you accepts and rejects. It needs an agent, and it is Grafana ready via CloudWatch namespace. Now, if we were to use VPC flow logs, you don't get round trip time or packet loss. Traditional NetFlow, I love traditional NetFlow, but it actually doesn't look that great. Okay, interesting. All right, bottom line, network flow monitor is the closest AWS gets to a NetFlow from Nitro-like thing. Okay, well, any questions you folks want me to ask this thing, just post them in the chat while we wait for Jamie to reconnect. Maybe his internet broke. And actually, in the meantime, I guess I can talk about the scenario that happened to me over the weekend. So I don't normally get paged, and I'm not normally in the support line of people to call because I'm a solution architect versus an engineer or in a support organization. But over the weekend, I actually did get paged, which is a super rare thing. It's happened once in the last like 5 years, and we actually had a customer that was trying to do some data transfer. And so this particular scenario, and maybe you folks can give me some suggestions on how we could have solved it better, but this particular scenario had it involved an outpost, and we had to rehome that outpost to another region, and we had some data that was stored in a region, and we need to transfer that data to the new location. And so if I was to summarize this in a problem statement, basically what we needed to do was transfer about 5 terabytes of data from one, let's say from one region to another, even that could be our summary here. And we were having problems with latency in that we were seeing about, I think it was about 150, almost 200 milliseconds of latency. And so doing a typical TCP data transfer, we were only getting, I'm going to say about 1 meg or 2 meg or 10 meg. There was some problems there, and I think they were actually using on premises and there was some firewalls in line, and so the data transfer was actually a major problem. Now, what we ended up doing through using something like this, and I could even ask the question: I need to transfer 5 terabyte of data. What would be the best tool to do that? Should I use TCP or maybe UDP or a different TCP algorithm? So I'm kind of leaning towards the answer that we found, but basically transferring data was going to be a problem. We couldn't load it on a truck and drive it. We couldn't ship hard drives. And so what we ended up doing was saying, okay, well, if we, there's actually some great answers here. We were saying, okay, if we use UDP-based data transfer and doing an iPerf between these two locations, UDP was getting 2 gigabits per second. TCP was getting 1 megabyte or 1 megabit per second, or 1 megabyte per second. So then we were thinking, okay, what if we were to use secure copy, or if we had a version of that used UDP under the hood? It just turns out that someone wrote a thing called QCP. I don't know if anyone's ever heard of that, but QCP basically does a data transfer using SCP for the security mechanism and session setup. So it uses SCP from one host to another, and then it initiates QCP in the background and uses UDP as the underlying data transfer. So we ended up trying that, and we went from 1 megabyte per second to about 50 megabytes per second, which is actually a lot better. Now, based on this testing, again, we still thought we could do better. So we ended up trying TCP and changing the TCP algorithm from cubic to BBR. I think, do we mention this here? Yeah, there we go. Okay, so this table's messed up, but UDP-based, Aspera, Fast, UDT, using QUIC. QUIC was actually the QCP version, or QUIC was what QCP was using under the hood. But then White MMC. What's White MMC? I don't know what that one is. Let's ask it, Victor. I don't know if you want to post that in the chat. What's White MMC? Is that a different TCP algorithm? So the end result, long story cut short, was UDP with QUIC was great, but the overhead of using SCP as the encryption and auth and setup, and then quick encryption, it does TLS 1.2, I think, under the hood, we weren't getting as much as if we just used TCP and changed to BBR, which basically handles latencies a lot better than what Cubic does. So here, quick math for 5 terabyte, 1 gigabit was 12 hours. Okay, why the difference 50x on UDP compared to TCP? Yeah, so it's super interesting, right? You would think UDP would be better, but not 50x. And so in this particular scenario, because I mentioned an outpost, but we were going from a region to an on-premises site, we think there might have been a firewall there doing something with TCP. And that could be, for example, if you have a firewall that is doing deep packet inspection, that can add a bunch of latency. I'll give you an example. So I used to manage a DDoS system in the public internet. And when we would inject a BGP prefix into the public internet to take a route for a particular traffic we wanted to clean, we would send that to a cleaning center, DDoS cleaning center. We would then look at every packet and clean out any ICMP, or if there was a whole bunch of TCP SYNs, we would clean those out. That added about 300 milliseconds of latency. So you get clean traffic popping out the other side. But with TCP, now you've got 150 milliseconds between these two sites, plus potentially 300 milliseconds if we're going through a deep packet inspection system, which is just going to blow out any TCP sessions, right? Now, if we use BBR, that has a lot better mechanisms to deal with latency. Or if we use UDP, you just send the packet and forget, right? So UDP is kind of not really affected. So that would be why you would see a 50x difference on UDP versus TCP. All right, I'm going to ping Jamie and just see what happened. Oh, he has a personal issue that just happened. So Jamie's unfortunately not going to be coming back on. Okay, not to worry. All right, well, we might have to cut it short today just because we lost Jamie and he was going to talk about a bunch of other stuff. But I do want to show a quick output here. I actually asked, based on the situation. Oh, here we go. We've got Dragunov, we've got a question. Don't really know what I'm talking about, but could you use UDP and then do an error check after the file gets there? Yes. Okay, so Quick was actually doing that. And so let me bring up this. I actually asked Kiro to build a guide for me, and maybe I can share this publicly to folks at some point. But so based on all of the inputs that I was working on during this issue, we were I said, okay, let's build out a guide on how we can use QCP. And I'll answer your question, Dragunov, as we're real-world problems and solutions. I agree. So this is a good conversation. So again, problem is, should we use UDP to transfer this 5 terabyte? UDP doesn't have any error correction. We could do a SHA hash on the file as it lands, when it lands at the destination, and then confirm that the source file works. But this transfer is going to take probably a couple of days. We're not getting like gigabits a second. We're getting about 50 megabytes per second. So bytes per second. So what we ended up trying here was, all right, let's try to use QCP. And what that would do under the hood would say, let's use UDP for the data transfer. So we potentially are no longer bound by the latency of it. We have TLS 1.2 for encryption, so that's great. Then this is how you would actually configure it. But QCP, which I don't have the gentleman's name here, but this is written, it's open source, it's publicly available to download, but it actually uses some error correction and checking with the Quick protocol underneath the hood. So you get kind of the best of both worlds. So definitely one of the options we were considering. But the end result was we ended up using BBR, and it actually operated a little bit better than QCP and UDP. So there's your answer. But maybe I'll release this as a public note, or I'll write a blog about it at some point, because it was an interesting process that we went through to say, we need to get this amount of data from one side to another. What's the best way to do it? Is it UDP? Is it TCP? Is it TCP using Cubic? Is it TCP using BBR? What are the mechanisms at play here that we could do to get this data transfer to run better? Okay, I'll stop sharing there. And actually, I just need to message Jeff here internally. All right, let's keep rolling here. Okay, so Code with Sean, you have a question? Yeah, I may be bringing Aviatrix for multi-cloud connectivity. What pros and cons can you share? All right, I don't have my whiteboard plugged in today, but I'll try and describe some pros and cons with using Aviatrix for multi-cloud connectivity. So Aviatrix is, they're a great partner of ours, and there's a couple of folks over there that we work really closely with. But what they basically do is they build an instance-based service. So they use EC2, and that service then runs VPN. And so whether the underlying connectivity is direct connect or public internet doesn't really matter to Aviatrix so much. So what they do is they'll build an EC2 instance in AWS. they'll build an EC2 instance in another cloud provider, and then they'll build VPN tunnels between the two. And I think they have what they call insanity mode, where they basically build a whole bunch of tunnels and then they flow hash across those tunnels, so they get beyond things like 5-tuple limitations using things like IPsec, right? And so you can get, I think, 100 gigabits per second between these instances if the instances are big enough, right? And so this is actually a great way to interconnect cloud providers. Now, what we recently launched, and let me bring that up again. We'll go back to our Kiro CLI. What was the multi-cloud launch that we recently did? So folks who are just joining us, I ingested all of the AWS blog posts recently for the last 12 months. I did this morning, and so we can ask this thing questions. I do a shift. We recently released multitasking. My grammar is horrible, but we recently released publicly GA AWS multi-cloud for Direct Connect. And what we've done there, and I'll get to Code with Sean, your next question there, but we pre-built NNI connectivity between, say, GCP and us. So let's see what it comes up with here. Okay, AWS Interconnect multi-cloud launched December 25 at reInvent. I think it's recently GA though. That was a preview. So AWS Google Cloud collaborate to simplify multi-cloud networking, build resilient and scalable multi-cloud connectivity. Built on Direct Connect or Direct Connect Gateway. It has MACsec, quad redundant. You can use VGW and Transit Gateway. What does this all mean? Well, basically, we talked to GCP and said, if we pre-provision fibers from your point of presence to our point of presence, then we can build an orchestration layer on top of that so that customers can say, hey, I'd like to connect to GCP. And you get a slice of that physical networking. So what you'd previously have to do is talk to a data center provider, deploy a physical router at Equinix, for example. You would have to build an NNI, a network-to-network connection from that router to us and also to the cloud provider, run BGP on both ends, and then route everything through that physical device. Now, folks like Equinix have their Cloud Exchange, which they do that for you, but now you can actually just use a direct cloud-to-cloud NNI. So it's actually pretty awesome. Thanks, Victor. Appreciate the comments. So the multi-cloud capability is basically, hey, I just want a physical fiber and I want to use a slice of that between these two clouds. So definitely worth checking out. Coming back full circle to Aviatrix. So Aviatrix could run on this multi-cloud connection, and you would basically get the ability to have a hub in two VPCs using this capability and fan that out to other VPCs as well. And again, I can't draw it here because I don't have my iPad set up today. I'll make sure I do next week. But there could be some benefits to that, and I'll let Aviatrix, their documentation talk to that. But the downsides are you have two EC2 instances on either end of the pipe. And so what would happen there is those EC2 instances need to be large enough to handle the amount of traffic you want to take or send from one cloud provider to another. You also have some increased latency. Now, EC2 instance to EC2 instance latency is 0.5 milliseconds or something in the same availability zone, pretty low. So it's not a big factor, but there's an extra packet processing path, right? And the same goes for if you had a direct connect with a VGW and a native connection, or you use something like Transit Gateway, which goes through a packet processing fleet and adds about a millisecond of latency. So even with native AWS services, there's increased latency and there's a fleet there involved. But anyway, I'm waffling a little bit here. So Sean saying, thanks for the questions, Code with Sean. I'll be connecting Azure, AWS, and 2 private cloud data centers. Okay, so in this case, we've got our multi-cloud option here that's only between AWS and Google Cloud right now. And so I don't know what our roadmap looks like there, and this is public, so I can't talk about roadmap, but feel free to reach out to your account teams. They know how to talk to me. We can talk about what we would be doing with Azure and other cloud providers. But I think the key thing here is 2 private cloud data centers. And so the question I would ask in this architecture is, how much bandwidth do you need between AWS and other cloud providers and AWS and on-premises? And based on that, the amount of bandwidth you need and the latency and whether you need encryption, you could either use a combination of everything I've just talked about. You could use your own direct connects and native connectivity to Google. You could use Aviatrix to connect to Azure via VPN, via internet, or you could build a direct connect natively, or you could use a partner like Equinix Cloud Exchange. To get to your on-premises data centers, you would have routers there at data centers that you manage and deploy, some colo facilities somewhere, I'm assuming. You could then build VPN over an internet circuit, or you could natively build direct connect from those sites up into AWS. Now, I think the key thing to think about is how you manage all of that connectivity. And so you could use Transit Gateway as a hub. You could use Aviatrix as the hub. They do that quite well as well. You could also use something like AWS Cloud WAN, which connects all of your regions and has the ability to connect direct connects and VPN and direct connect gateways, which could be connected to multiple cloud providers like GCP, like this multi-cloud network. And so Transit Gateway under the hood, but Cloud WAN basically becomes this dedicated fabric of connectivity that you could build, right? So something that could be worth exploring as well. All right. So yes, that's right. There's many transit hub options, and actually, bit of a history lesson on transit hubs. So we used to see a lot of architectures where folks wanted a transit hub in AWS, and they would actually use EC2 instances like a Cisco CSR connected to VGWs, and that architecture. The way it basically works is spoke VPCs with VGWs, VPN connections to a set of instances in a central hub VPC, and then you can interconnect all those VPCs or on-premises via VPN or even direct connect. And that was basically your transit VPC blueprint. Now we took that and said, okay, everyone's building these transit gateways, transit VPCs. Let's turn that into the transit gateway service. And so the legacy of what you see with transit gateway and cloud WAN and this multi-cloud connectivity and direct connect gateway, all of these hubs and options you can build really stems from that very first transit VPC architecture that we saw customers building. So you can see that we've built from that requirement and just started bolting on different add-ons. And actually with Aviatrix and other SD-WAN providers, we have Transit Gateway Connect, which allows you to have a head end for an SD-WAN if you wanted to extend your SD-WAN into AWS as well. So something that you can think about too. All right. Well, I think I've shared my QCP, UDP versus TCP issue that I was working on over the weekend. I'll think about turning that into a blog post. We have a couple more questions here. Thanks, Sean. Appreciate the comment. Okay, we've got another one here. So Azure and OCI to be added later in 2026 as per AWS Interconnect multi-cloud documentation. So let's talk about roadmap stuff for a second. We don't normally share roadmap. I think in this case, they've added this to the docs. I didn't see that, so thank you, Venkatesh. Appreciate that comment. But basically, I think it's probably important that the multi-cloud folks, the Direct Connect folks, talked about this publicly because everyone's going to want to connect to other cloud providers. I'd be interested to see where else we take this, actually. I like the fact that we have MACsec as well, built natively into this. I think we call that out here. Very cool. All right, well, I think we've got about 12 minutes left, but considering we lost Jamie today, and unfortunately, he's not going to be rejoining back because of a personal issue. One of the key things we wanted him to talk about was some of the coordination work that he's been building around Hero CLI. And what you see here, I think I can paraphrase, but what he's essentially been doing, and I think this is actually incredible, he's been ingesting a whole bunch of networking documentation like I did here with the blog post, building context, but then he basically built a backend database which shares context between sessions. And so I think the idea is, and we'll probably present on this in the upcoming weeks, but he's trying to build, basically it's like a Kira superpower, but not official yet, but the ability to say, hey, I'd like to deploy something on AWS. I'd like to maybe code with Sean's architecture. I'd like to deploy a multi-cloud architecture with Cloud WAN connecting to my application VPCs, and I'd like to have some other form of database and application, and then basically spawn sub-agents through some context like this. and one goes and deploys the application, another goes and deploys the transit gateway, another could be some form of arbiter to say, hey, hold on a second, what we're building here, is this using AWS well architected or not? Potentially not, and stop sub processes that end up building transit VPC architectures because they seem to make sense, not knowing that there is a transit gateway or cloud WAN thing that you could build with, right? So building networking architectures on AWS could get far simpler in the future. And I'll give you a bit of a viewpoint into some of the stuff we're thinking about internally, just some thoughts. So this is Matt Lewis's musings on the future of networking in AWS. Prior to LLMs, we were actually thinking about how we can make things simpler, right? And so how we could basically say, let's build some kind of network intent policy language where you can define your application and define the connectivity it needs. So when you think about networking, it's all about connectivity, right? And so we were looking at potentially building a brand new service like VPC Lattice, but basically way simpler. I have an application. I want to deploy this application. Here's the intent of that application, and it can connect to these other things. And everything gets orchestrated and built under the hood. Now, based on things like Kiro CLI and LLMs and how they interact with Lego bricks, what we were trying to actually do was build solutions and not components. But now we basically have that anyway, right? So you can plug this into any different type of Lego brick. It understands how to use that Lego brick and then orchestrates that for you. And so what I'd actually like to do is see some more observability and visibility built into this, where I can have 5 different sub-agents that go and build and monitor different things in my AWS cloud network, and then modify and change those architectures as applications change, right? And this has happened I've been playing around with Kiro CLI since we changed it from Q, and I think every time I play around with it, it's incredible. But the change has actually been less from science project to more in that, like what Jamie's building, where I'm going to build a superpower here that actually monitors and builds my AWS networking infrastructure, right? And give me feedback on what's actually happening out there and how I can change things and how much this stuff's costing, right? Building a orchestration platform previously was, again, orchestrating and building Lego bricks. You've got a Prometheus agent pushing things to Grafana and CloudWatch and trying to build some kind of reporting and visibility. You can do all that natively with these types of tools. So I'm super excited to see where that's actually going to take us. And I'll end us on that. But Victor, yeah, I agree, right? The innovation is just wild, and it's going to be super interesting what we see over the next 12 months, actually. And what I was originally asking, what the reInvent session should be for, I'm not doing advanced VPC design this year. I think Alex is going to do it. Alex Hudej will do it again. But it'll be interesting to see in the next six months, in the lead up to reInvent, how this blueprint will change based on new features and services, but also the power of using things like Kiro CLI and other LLMs that are plugged into it. And, do we need to actually care about crafting architectures manually anymore, or will this just go and do it for us? Maybe. We'll see. Anyway, I'll give you folks back 7 minutes today. Apologies for Jamie having to leave. I hope everything's all right on his front, and we'll see you folks next week.